dying.
You give up too much energy, you can't keep up.
Yeah. So you choose the row you want to use to find determinant. And in general, any row will work. You can use first row, second row, third row, fifth row, seventh row. For my master's degrees, I was doing 7 by 7 matrices. So that was interesting, but it don't fit on the teach. And for the cross product, usually we do first row. So let's choose first row. It's in blue 2, 0, 3. Put like so 2, 0, 3. The thing is, matrices have this kind of property of the sign. Sign will look like so. Find some kind of place and write down. The first chosen term will be multiplied by plus, and then the moment you jump somewhere, it changes minus plus, minus plus, minus plus, minus plus. So people just remember that it alternates. When you jump, you have to change the sign. And that is why the sign is changing. Plus A minus B plus C. Because if you see from this diagram, this will be plus minus plus. If you choose the second row, it will be minus plus minus. Plus minus plus to the third. People don't memorize it, we just know how to remember the shape. So first two things you know, that is going to be, you chose first row in blue. Let's do like this, first row. So it will be plus 2 minus 0 plus 3. Each is multiplied by small determinants. Small determinants. What kind of determinants? And that's where the game starts. So, very interesting, Dr. Payam actually using this reference to a computer game, which I also played thousands of years ago, which is a bomber. I guess when there's a bomb here, it will blow up left, right, and up and down. So it destroys everything like this. Same thing happening in this matrix over here. When you work with this piece 2 times a determinant, you choose this 2 to be a bomb. So he even has like this, right? It blows up these guys. So whatever is left will be your determinant 2, 1, 1, 2. I will not gonna fix that. I will just show you his notation. And that's how you know. And so on. Then next time you choose, let me show you. Next time you choose 0, and remember it will be minus. Bombs and bombs. Now you have 1, 1, 4, 2. I never imagined as bombing, to be honest. I imagined it's a Lego piece. So I was like, okay, this thing has a Lego here and Lego here covering it, so I don't see it anymore. Whatever is left, I will write it down here. That's how I imagine it. It doesn't matter. Or you cover it with your hand, also the way to explain it. And finally, the third one, when you choose 3, this piece, don't see, 1, 2, 4, 1, 1, 2, 4, 1. Does it make sense? You do it a couple times, you get used to it, you become fast at this. So this is what he's showing here. You have those 3 nicely looking determinants. So now you can actually write it down as, so now I'll write down by hand for you, because I think that is important to show you. When I see, actually one more thing to mention. When you look for determinant for 2 by 2 matrix, determinant for A, B, C, D, that is one is very easy to find. You just do cross minus cross product. A, D minus C, B. So this long procedure works for upper level matrices, but not for 2 by 2. For 2 by 2 it's simple. Why I'm saying it? Because right now we need to work with 3 2 by 2 matrices. 2, 1, 1, 2, 1, 1, 4, 2, 1, 2, 4, 1. Each will be just cross product minus cross product. That's the rule. So I want to show you how I'm doing it without this long explanation, so you can see what kind of people are expected to do. This is what we test in the class where we teach matrices. Actually, business calculus does that. 211, we teach the matrices and this stuff. So if I ask to find the determinant of this matrix, I will do it from scratch, and I will show you how I'm doing it fast. I'm choosing the first row, so it will be 2 times. And instead of showing this determinant, I immediately open parentheses, and I'm writing in, let me do the different color, 2 times 2 minus 1 times 1. Did you catch what I just did? Yeah. This, let me know if you didn't, because that is a lot of weird little steps. But if you do a couple times by yourself, you kind of get it. So here it is. Then I remember it should be minus 0. And to be honest, since it's multiplied by 0, I can stop here. But whatever, let's do the whole thing. Open parentheses. And now look at this. So I saw that this one was used. 2, 1, 1, 2. We did that already. Now when I choose 0, I will do 1 times 2, 1 times 2, minus 4 times 1. You see? So I'm doing it like so. Like I'm seeing Lego pieces covering stuff, and whatever is not covered, I should multiply cross product. Oh, 4 times 1. Finally, plus 3, plus, so not minus anymore. Sign does not change. It did change, so it's going to be plus, minus, plus for this row. And then for 3, I close these guys, and I look at it carefully, and I see 1 times 1 minus 4 times 2. So this is how I do it in my mind. That's what you'll be doing it in your homework on the first exam. And now you calculate. So this was this guy, and this was this guy. I will stop here. Does that make sense? That's how we find determinant of 3 by 3 matrix. Same 4 by 4, 5 by 5. Just determinant will be bigger on each set. So I was using Maple and R to do upper level matrices for my master's research. And now you calculate everything carefully. And then what you get the number, let me see, minus 15. Minus 15, put it in the box, that is the answer. So we just found determinant, we did not even do cross product here. But that's what I wanted to show you, how we're doing it here. Here's the formula for 2 by 2, by the way. I should have put it higher, but it's fine. Make sense? Some of you, did you see this kind of way?
Yeah, no.
That's the one I don't know. I saw several students submitting it, and I always tell my graders, this is correct way, I just don't know it. But I mean, I can see it makes sense from the first glance, but it's not internationally known, I should tell you. This one, I think it's either local or at least I don't know it. So I keep it here just for you to, if you remember it, then you know it. It's called diagonal calculation of determinants. But again, nobody memorized the formula. Everyone just do this process I just did. Nobody remembers this. So that's not what we ask people. Do you remember the formula EFD? What is going on? No, you just need to know how to get it, how to derive it. So 2 by 2 is easier. Cross minus cross. Applications. Just like 2 by 2 determinants are used to calculate areas of parallelogram, 3 by 3 are used to calculate volumes of parallelepipeds. So areas for 2 by 2, volumes for 3 by 3. That is very practical, lots of stuff. But don't forget, you might get negative sign. So if you get negative sign, just take absolute value. If you're actually looking for area or volume, because that's what makes sense. Let's do cross product. Cross products, it's the hardest product from vector products. So we know dot product. Dot product gave us the answer how parallel one thing towards another thing. If it's very parallel, cross product will be huge, either positive or negative. If it's very not parallel, which is close to perpendicular, it will be very small. It will be 0 when vectors are perpendicular. Cross product will give the opposite question. Answer the opposite question, how perpendicular things are. And unlike dot product is the number, cross product is a vector. So that is very important. That's why sometimes they call it vector cross product, as you can see here in the formula. Write this formula down. This n is not going to be covered in our book, so we don't need to have it. But these are two formulas. You will this formula you have to memorize it, and the second formula I will show you the same way. You don't have to memorize it. It's too small for you. I don't have to memorize it because I know how to derive it using determinants. Okay, like so. So, vector cross product formula. Here's the idea. I will show you nice, look at this dude, Scott. So, here's the idea. There's a nice animation over here. When you have two vectors, say they are on a board. So, this is the plane. They are in 3D, as you can understand, they are flying in 3D. But two vectors create a plane, right? So I can always put them on some kind of plane. Say I move them to the whiteboard. Is it possible to find a third vector that will be perpendicular to both of them? They might not be perpendicular to each other. They might be just random vectors. But can I have one that's perpendicular to both of them? Yes. One either going to be sticking towards you or going towards the whiteboard. That's a pretty cool idea of this 3D space, that you can actually find a vector like this and either define it or use it as a property. See? So vectors can be different. Right angle, not right angle, parallel, not parallel. But there's a third vector, which is found by cross product, which will be perpendicular to that plane. And you see it's either looking up or down, or in this case, towards you or towards the board. So that is why the answer is a vector in this case. Here is the idea. Two vectors, to draw this idea. Two vectors, A and B, they create parallelogram, as you can see. This creates area. What is going to be the third vector that is going to be perpendicular to both of them? That's why they are squares like so over here. This one and this one. It's perpendicular to the whole plane. Soon we're going to learn planes. To the whole plane or parallelogram. And that is what we call cross product. And to define cross product, you literally put a cross A, cross B. That is why when I see you have bad habit to put cross for multiplication, it's a bad habit from school you attended. Nobody should doing that. I see some of you do 5 times 10. It's a bad habit. Don't do that. 5 times 10 is a dot, because cross is already reserved for vector spaces. So that's important. I always mention Calculus 1 class when I see students doing that. Now, so the 0 in the length cross product is in blue. See that blue sticking up vector is either 0 or it has a maximum. Let's see. If cross product is a perpendicularity to both vectors. So when do you think it answers the question how perpendicular vectors are to each other? So when do you think it's going to be least perpendicular? When these two vectors A and B are what?
Oh, they have each other in a straight line.
On top or line or parallel. So this vector will be 0 in length when vectors A and B point in the same or opposite direction. That means they're on top of each other or on the same line, because they are perpendicular at all. When it's going to be the longest one? When it's going to have a maximum length when vectors A and B are at the right angles. That's pretty cool. There's a third vector that gives you information about the other two vectors. How do they behave? And this is why this animation is so cool, because as you can see, when they are on top of each other or on one line, this third vector, cross product vector, is 0. But you see, it keeps growing when it gets to 90 degrees, decreasing, growing 90 degrees, decreasing to 0, and so on. So that's very cool how they show it here. First of all, it's changing direction. Second of all, it's the biggest when these two are 90 degrees. How awesome is that? So that is a lot of information, lots of properties are coming here and very useful in physics and engineering. Here's a nicer picture. So you don't have to copy this one, but this one shows it can go up and down. And how to, let me show you this. Yes. So if in 2D we have parallelogram, in 3D we have parallelepiped. Look how nicely, you don't have to care about the matrix on the left. I really like this one. This is pretty cool animation. 3 vectors create parallelepiped. It's not necessarily right angles there. It might be tilted. You see? And they're floating in the air. How awesome is that? And that means cross product will help us to find volume of parallelepiped. So let's practice and calculate some stuff. Calculate A times B. Let's do that. Let's do that. For A and B given. So cross product. First of all, I will show you how you're going to be doing it for a while, and this is what you're going to be doing. It's a long process. It's not too long, but you have to be careful and tedious. So students who are very good in being careful will do better just because they're careful. Maybe have more spaces when you work with matrices. That helps a lot. We are going to write down A times B. You see, times can be different. A times B is not the same thing as A times B. The second one is a dot product, will give you a number, and we know how to do it, right? 1 times 4 plus 2 times 5 plus 3 times 6 and so on, right? But cross product is a matrix, is a determinant of the matrix. What kind of matrix? You put I, J, K, our favorite trio, famous trio, and then you put each vector in a row. 1, 2, 3, 4, 5, 6. So you create this 3 by 3 matrix, but one row is missing, and we're going to be using IJK. IJK, yes.
So A cross B is not the same as B cross A.
That's going to be in a second. Yes, very good point. And then I can ask you in a moment when we finish this, what's the difference? But yeah, I'll show you in a second. Good catch. So, because matrices are not commutative, so you cannot just flip them. So, who remembers what are I, J, and K? That's also a very good question to ask. You're kind of supposed to
These are unit vectors.
recall. First of all, yes, good job for remembering the terminology. Unit vectors, basis vectors, right? Basis vectors and so on. And then, what is I? 1, 0, 0. So 1 at the x-axis, but 0 everywhere else. What is J? 0, 1, 0. Good job. And K? 0, 0, 1. Excellent. So you need to know this. This is very important. This is like what is x, y, and z. This is what I, J, and K. They indicate each coordinate for corresponding axis, x, y, or z. So length, depth, or height. Now, we just need to find this determinant. And I just show you how to do it on a simple example with numbers. This one, just the whole difference, will have IJK. So I'm choosing the first row, and that means it will be I minus J plus K. Remember the plus, minus, plus thingy? So this is already done, right? Now, either you write down each determinant if you want, or you can immediately do cross product. Cross minus cross. So, not the cross product of vectors. Cross multiplication of numbers. That's what I want to say. So, should I do once a long way? Let's do once long way. When I multiply by I will have determinant. I'm imagining I destroying this column and this row. So 2, 3, 5, 6 stays. Make sense? Bless you. J, I don't want to do too much. Who's sneezing over there? Do not, do not sneeze. There's a that is scary. Nowadays it's scary, you know. There's a joke I told my students in 251 class on Wednesday. Oh, my students know Russian saying, if someone sneezed after I finish talking, it means whatever I'm saying is true. So you see, I'm doing a good job. 1, 3. It's a very, very dead joke in Russia and Ukraine, but like you guys don't know it, so I always saying it. So funny. Americans don't know this joke. Okay. 1, 2, 4, 5. Your job is not to forget the negative sign over here. Don't forget about this negative sign. So usually I don't even write down the small determinants because I remember. So let me put this recall separately. I remember how to do now cross multiplication. It will be I, parentheses, 2 times 6 minus 5 times 3. And if you're good in algebra, you can just calculate in your head right away. Minus J, 1 times 6 minus 4 times 3. You see what I'm doing? Cross minus cross. Cross minus cross. Plus K, 1 times 5 minus 4 times 2. And I, J, and K are vectors versus things inside are numbers. Numbers times vectors give you vectors, and that's why the answer is a vector. The answer should be a vector. If you get some, on the exam I can see I'm grading and the answer is like 55. And I'm like, no, that's a cross product. It should be a vector. So that's how I know you messed up. Calculating, it's going to be minus 3i. Minus 3, right? 12 minus 15, yes. Plus 6j minus 3k. Vector, vector, vector. The answer is the vector. How to write it down in the short notation? You put brackets, minus 3, 6, and minus 3. If you did not do homework right now, you don't understand this step. So it's very important that you understand. Every vector can be written in terms of I, j, and k. You have to practice doing it in your homework. It's not complicated, but it's new, so you have to practice it. I means x coordinate, j means y coordinate, k means z coordinate. So this is a shortcut. Or we can be playing with the basis, and that's why it's called basis. Yes?
On quizzes, if we don't put the arrow on top of vectors, are we going to lose points?
That's a good question. I should decide on this when I give quizzes. You should put, I will tell Isaiah maybe to take points once and then probably stop doing it. Good question. I will think about it. It's remember when you was learning limits, like we punish you for not putting limits at first and then we stop doing that?
I don't remember that.
It's kind of the same thing. Oh, you always got punished? Okay. So, yeah, good question. I will decide on this when I will be creating a quiz. So, remember, it's a vector. Let me write down again one more time. It's a vector. What is the vector? Who knows? What's the vector? Direction and magnitude, right? You should know that. Direction and magnitude. So, questions? You see, we found. That's your homework going to be. You're like, oh, I can do that. Just kind of lots of work, but not a problem. The thing is, you can also check that it's a correct answer, and that's good news for you, that you can do that. Let me have some good news for you. You can check. Okay, let me do here. To check that this is a correct answer, we can multiply this answer. Let me call it. This is A cross B. We can multiply A cross B times, and we can do dot product with A dot product. And we can check and multiply and get a dot product with B. Who can guess, if you understand what is going on right now, what should be the answer?
0.
Why?
Perpendicular.
It's perpendicular to both, exactly. This is my A, this is my B. We found this vector, either going this way or this way. When we found it, which has numbers now, it is minus 3, 6, minus 3. Minus 3, 6, minus 3 is perpendicular to both A and B. What does it mean to be perpendicular? You can take dot product, which is easier to take, and it should give you 0. Because dot product gives you 0, and vectors are perpendicular. Do you remember that? So, let me write down the first one. It looks complicated, you see? Now you have two types of product in the same line. How awkward is that? So, I will write down like so. Minus 3 and 6 and minus 3 multiplied, that's a dot product, by, what was A? 1, 2, 3. 1, 2, 3. Who can tell me what is the result of that? So minus 3 plus 12 minus 9. Is it 0? 0. So you see, very fast you checked and it should be 0. Let's check the second one really fast. Same thing. Minus 3, 6 minus 3 multiplied by 4, 5, 6, right? 4, 5, 6. That's just a guess. Was it 4, 5, 6? Yeah. Let's check. 3 times 4 was negative, minus 12 plus 30 minus 18. Is it 0? Yeah. 0. Checked. That is because we have two vectors. Let's say it's like so, A and B. And we found a third one, A cross B, which is perpendicular to those two. Perpendicular gives you 0 when you take dot product. So this is dot product. Ask me, did you just check your email for a second and now you have no idea what's going on? Can you get it? Yes.
Is this gonna be like last semester where you made us put that we checked on our piece of paper that the answer is correct?
What?
I remember in some of the homework quizzes, you made us put that we checked our answer after we solved it.
Oh, maybe. We'll see. We don't usually require to check, but it's nice to know that you can. So if you have 10 minutes left in the exam, it's nice to check. Yeah, we're going to do this right now. Dancing with So any questions about this? What did we do here? What is going on? Ask me. This is very nice. You can ask. You can always say, I just dropped my pencil. Now I don't know what. But that's exactly what just happened. I just wrote down lots of stuff for no reason. Yes.
We're given three vectors that cover all three x, y, z, and where will the cross product of that be?
So I'm going to show you right now in a nice picture. More questions? Yes?
With A and B, are they always on the XY plane? Or?
No. A and B also, so this is exactly what also is asking, I think.
Oh, okay.
Everything is floating in 3D. I will show you right now, very nice animation. But because two vectors create a plane, I can always take it and like smash it on the wall. So no, they're actually in the air, like in 3D air. And the animation I have is here. I think this one. Yeah, perfect moment. This is exactly what's happening. A and B are floating, and we're creating a third one, the cross product. Pretty cool. And so we're gonna learn how to call it differently, normal vector, and so on. But this is what's happening. There's three vectors moving around. In this case, there are three orthogonal vectors. In our case, actually, they're not necessary. All three orthogonal. This might be different in English. But this is what is happening. A and B floating somewhere in the air, and then the third one is perpendicular to them. How cool is that? Yes.
Could you explain the zero again?
The zero? Yeah. The zero is like so. When I found this vector, look at this. This is a good explanation. I found this blue vector. Blue vector is perpendicular to B and perpendicular to A. From the previous lecture of dot product, we know that when A times B are perpendicular, dot product should give you 0 because cosine of 90 is 0. So that's why, right? And because dot product also answers the question how parallel I am to you, if I'm perpendicular to you, that's 0. That's what I did. So I just found dot product of this with A, and then of this, with A and B separately, and it gave me 0, and that is correct. That means my vector indeed is perpendicular to both of them, just like I need it to be. Very good question. Good job, people. Ask questions. More questions? Yes.
We were trying to find the cross product of 1, 0, 0, 0, 1, 0, and 0, 0, 1. Where will the cross product vector be?
Well, you choose 2 for cross product. So one of them is a cross product of another 2. Yeah.
You can't have like 3 and find one that's perpendicular to all 3.
We will actually be talking about this soon, but no. For now, we do 2, and the third one is the perpendicular. The vectors are interesting to look at. Yeah, we do. We can do more than 2, of course. But the matrix will be longer. That's okay. You remember? So you can have one more like so. And of course, you can find this sticking out perpendicular to all of them. Then you will have a bigger matrix. I, J, K, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you proceed with the same situation as you had before. And also you will,
But you will need 4 dimensions though, because if you have one.
Yes, you will have to add one more basis. You're right, it will be 4-dimensional.
So it will be 4 columns?
Yeah. That will be a pretty nasty calculation to do. But no, good question. Usually people choose 2 and then add IJK, and then they could choose another 2 and do IJK again. So they can do it as often as you need. Yes? Yes? IJK is a vector, so each is 1, 0, 0, 0, 1, 0. I know what you mean there. You can put it in your calculator. But IJK a vector, so it's not a number. That's a smart question, if it makes it easier or not. So let's play with the right hand again. This is, again, left-handers. I always do it wrong because I tend to use my left hand. I'm like, why doesn't it match the picture? Oh, okay, it should be right hand. You know, the world is set up for right-handers. So first of all, it's important what I mentioned. A times b is a vector perpendicular to both a and b, and that is why we just did this check. So since it's perpendicular to both, we checked using dot products. Note, yeah?
I was gonna say, it looks like a little like person doing the thing.
Or it looks like Professor Game Time.
So, like I said, it's either looking towards you or against or to the wall. So which one is the one we need to choose? And this is what people agreed on. When you do cross product AB or CD or MK, whatever is the starting one will detect where the cross product will look up or down. So you take those three fingers and you start folding these two. If A folds towards B, so the first one you multiply towards, folding first towards B, then the sum goes up. And that means cross product is over there. What if I do B times A? I will have to flip it down like so. And now when I fold B towards A, it will look down. So A times B equals minus B times A. That is how it looks over here on this picture. Let me repeat it again. Where did you go? Let me repeat it again over here. And it's nice that it has different location here. If, let's practice again. See? I'm holding those two fingers. I'm folding A times B. Looks up. So if I'm folding from A to B, the cross product will look up. But if I do B times A, to do this, in order to start folding from B, I need to flip my hand down. See? Now, B goes towards A when I fold. And it looks down. It's the same vector, but it's completely opposite direction. So you can find one of them and then take the minus sign to find another one. So, A times B is minus B times A. So that is a little bit challenging idea because it can be anywhere. As you remember, it's floating in the air. These two might be like over here. The third one might be looking down. So you need to have the imagination and fingers folding skills. Fold and go up. But it's funny that everyone around the world doing exactly the same thing. That's how they teach it everywhere.
Forward again.
Yes. So let's see. This is what they call, if you Google it, right hand property. Other properties, which are not very important, so you don't really have to copy this. You can just have it in your notes later. Again, if A and B are parallel, there is no perpendicularity, so A times B gives you 0. That makes sense. Because again, cross product is about perpendicularity of two vectors. Since A parallel to itself, A times A also gives you 0. B times A is minus A times B. We just checked that. This is what you asked about I, J, and K. Any, if you multiply, if you do the cross product, will give you the third one because they are orthogonal to each other. So I times J equals K, or I times K equals J, so on. Angle formula comes from the right triangle. Again, cross product magnitude of the cross product equals magnitude of A times magnitude of B times sine of the angle between them. Triangle, so it's again Pythagorean theorem every time. How do you feel about these? But the most important property is this one. It's a simple one, but most important. A times B, cross product, perpendicular to both A and B. That is what is used in physics and engineering quite a lot. I will show you at the end. So, looking good? Okay. So you saw this picture I already showed you. Fact. To find the area of the parallelogram, you need to find the magnitude of the cross product. And there's a nice cute proof which you can watch in the video from ASU. A is the base, B is the height. We know how to find area of parallelogram. You're like, I don't know. Well, you can always ask your phone. Okay, Google, what is the area of parallelogram? And it should tell you.
Hey Siri.
Base time high. Yeah, I did it in Zoom and that was funny. Siri or Alexa. In Russian we do Alisa, you know? Alisa, we have Alisa. Alisa is have temper.
Wait.
People compared Alisa and Alexa's like, I don't understand you. Thank you very much for asking. I'm ready to help. Alisa is like, what do you want? Repeat the question, dummy.
That's a more
So
realistic
it's like
assistant.
totally minus. People were comparing it was hilarious,
I
but
want one of those.
Alisa has a temper. So let's see. Either you find base times height, or using the idea of the cross product, you just take the magnitude of the cross product and it gives you the area. Remember what area is, right? Area of the parallelogram. Now, if you want to find the area of the triangle that you do, then you do half of that. So you will have it in your homework, you will see. You just find the cross product and then find half of it. That will give you the area of the triangle. Very interesting. Finally, here is the most important, which is used in engineering. Volume. Of course, in 3D it's all about volumes. Areas, we kind of know them from 2D. Why would you go perform long cross product if you can just do height times base? But volumes indeed are hard to find. Specifically, if you build a statue, what's the volume of the statue and so on. We're going to do triple integrals soon at the end, in the middle of this class. But cross product does the same idea. To find the volume V of the parallelepiped, in Russian we say parallelepiped. How different is that? You should choose any two vectors. I would say even three. Choose any three vectors, this one and this one and this one, and then build a matrix out of them. Pretty cool. So any actually is good, and in your homework and in your video you can see. You just need to, if you know the points of the parallelepiped, you can find the vectors. And then just make sure they're looking like so nicely, and you build a matrix out of them, and it will give you a volume. This is what has a weird name. Let me show you. So write down this idea. This is what they call scalar triple product. It's not a popular name, to be honest. I was surprised to see, so complicated. Scalar triple product, that's not how I do it. The way I do it, when I know the points that created parallelogram first, and then parallelepiped, who is here good in drawing. I know Maddie is good, Samantha was drawing really well. So if I know the points, I just choose any three vectors, and then I build the matrix out of them, and then I find the determinant of that matrix. That gives me the volume. That is a pretty cool idea. Of course, there is a cross product hidden here, but instead of ijk, they put the third vector on the top. So that is a pretty cool idea here. The volume of the parallelepiped determined by the vectors a, b, and c. And there's a cute proof how it went that way. You can check it out. I just gave you good notes. So we're gonna do example a little bit, but what I wanted to tell you is here, volume of this parallelepiped is, this is how fast you can do it. They give me three vectors, A, B, and C. Here they are. A is 1, 2, 3. B is 1, -1, and -2. And C is 2, 1, and 4. So I just build a matrix 1, 2, 3, 1, -1, and -2, 2, 1, and 4. That's it. Find the determinant of this matrix. It gives you a volume. It might be negative, so don't forget to take absolute value of that. But we just literally did that at the beginning of the class. We did this problem. So I can even tell you it is going to be -9. And you're like, oh, volume should not be negative. That means whatever you made a choice of those three vectors accidentally gave you negative direction. So you just take absolute value of -9. That gives you 9. And then units cubed. Pretty cool. So this is easier than to call it scalar cross product. That's a little bit overcomplicating things, to be honest. So you'll do this for your homework. And finally, physics and engineering people in the class should be happy to see this. Cross product in physics. Look at that. Look at that. So you know when you tighten a bolt by applying a force to a wrench, we produce a turning effect. That is pretty cool. So even I find it interesting. Okay. This is range, it spins, right? So you want to spin it. That is a perpendicular movement. But also the best way is to call it perpendicular as well, on the push, right? So there's just 3 perpendicular forces going on. Pretty cool. And then, here's a picture. Look at that. Pretty cool. That's kind of what the wrench is doing. It's spinning. It's spinning. So as you can see, the cross product shown over here. According to the theorem, whatever was the theorem, we don't have to call it 6. The magnitude of the torque vector is a cross product. How cool is that? When theta is the angle between the position and the force vectors. So that is pretty interesting what they showed here in this animation. So engineers, you will be building this quite a lot, and that's what you'll be using. You'll be using cross products. It's very popular actually in engineering and physics. And if you see it in the literature now, you know what it means. It's a cross product of vectors. And then I found this computer game kind of thing. Look at that. So funny. You're like, what is going on here? So also, this is used cross product. And then he's trying to teach AI to walk. And then it's like, what the heck is going on here? But he explains in the writing there in the website, he's like, I'm trying make AI learn how to walk. Using these 3 perpendicular forces, but they don't just keep falling. But that's what he wants. He wants this to roll, this to be perpendicular, and the whole thing also to be perpendicular. That is funny, but it also uses cross product. How cool is that? You don't know me. That's what computer scientists do when they create video games, okay? So that's good enough today. What do you guys think?
Horrible.
No, it's not too bad.
Especially when you mentioned the physics part.
Good job with the first week being done. Don't postpone your homework. And office hours will be super active next week, so don't miss out. Have a good weekend.
10.3 and 10.4 are due the 30th.